All right. So, what is the name of our lesson today? Let's try that again. Yeah. All right. Can we find our law of cosines on our cheat sheet? So what? This is extremely similar to law of sines. Yes. In fact, we're actually still going to be using law of sines. Yep, there they are. Yes and no. It really only has one. Okay.
Do we need our unit circle?
Unit circle? No.
Oh wait, hold on. Ignore that. I'm so sorry. My cheat sheets are like on separate pages.
Okay. All right. Now, what is orange? What is our law of cosines?
A squared.
A squared equals also b squared plus c squared. Okay. Now, yes, it looks like there's three different ones, but all they're really doing is saying, okay, whatever letter is here, same letter goes there. Okay. This is the lowercase, so that lowercase means?
Oh, it's on the opposite and it's on the opposite.
It's a side opposite that angle. And then whatever is here goes here, and whatever is here goes here. Okay? Yes.
Okay, so we're not using, there's no capital C's and D's.
That is the only, yeah, there's only one capital, meaning there's only one angle used in this.
We'll be able to like figure out the other angle, right?
Yeah.
We will. So we could get there. We're getting there. So this right here, I can find, well, I'm getting ahead of myself. Right here. So my situation is I have one angle, two sides. It lets me find my third side. Okay. But again, I can rearrange those letters. So for instance, here it gives me angle A. So that's actually the one I'd want. If they gave me angle B, let's think about what that would look like instead. So if this was angle B, what do I know also has to be part of my equation? I know I got to have, I don't like my new thing. Why don't it let me erase that? There we go. All right, I have to have a b squared there, okay? Those two letters have to match. And then I think there's only three letters. I just used the b, so the only other two letters are what? A and C. It doesn't matter which order, okay? So a squared plus c squared. And I apparently was erasing stuff. I didn't realize it. B squared, c squared. There we go. Okay. So that's why it looks like there's three different ones. They're just rearranging the letters. There are just three different ways you can rearrange the letters. Okay. So they're really all the same. Okay. So there's my law of cosines.
Which of the one has the capital letters opposite side of their thing?
Yes, that's right. All right. So to figure out which arrangement I'm going to use, I look to see which angle do they give me. Hey, so I'm going to use the one I just had up there, which is a squared equals b squared plus c squared. By the way, before I go further, what does that look a lot like? So all law of cosines is the Pythagorean theorem applied to all triangles. Because remember, the Pythagorean theorem by itself only works for what? Right triangles. So by expanding it a little bit, we're saying now the Pythagorean theorem works for all triangles if I add that to it. Okay, so it does come from our Pythagorean theorem. All right, so I'm just going to plug in. I don't know what A is. What is little b? What is little c? What is little b? C. And then my angle 134. So just plugging in what they give me into my equation. Now, that's a long stretch of numbers, but they're numbers. So this entire thing right here, is there any unknown in there? So I can stick that in my calculator just the way it looks, right? Make sure your calculator's still in degree mode. It should be.
No, we're not gonna square the whole.
Oh, excuse me. Yes, squared. My fault. Thank you. Again, if you wanted to. Yeah. Hmm. Okay. So we get that. What does that equal?
A squared.
That's a squared. No. Right? So to find out what a is, yep, we need to do a square root. Normally, whenever I do a square root, I have to do what? The plus or minus. Do I need to do a plus or minus here? Why not? Yeah, because this is the side of a triangle. It's impossible to have a negative side, so we don't need it. I will round it in the end. I'm just not rounding yet. Yeah. So 23, pretty much 23 even, right? All right, so we'll pause right there. So there are two important notes we need to finish these. All right, two important notes. We'll go right for this. Important note number one. We'll say law of cosines one time per problem. How many times have we used law of cosines on this problem? So I can't use it again on this problem. One time per problem. And the last one is we go smallest to biggest. And we talked about that briefly last time. It's the whole sine can give, there's two different values that sine can give us. That's why we have our two triangles. And it always finds the smallest one first. So we're going to go smallest to biggest. Let's think, what is it we have and what is it we still need to find? We have all the sides. I need two angles. All right. Could I have used law of sines to begin with? Why not? Didn't have a pair of information. Do I now have a pair of information? I have side A and angle A. So our next step is to plug into law of sines. Okay. And so there's my law of sines with my A's, right? Capital A over lowercase a. I need to use that to find one of my other two angles. Which one do I find? C. Why? Because it's the smallest. So we got some questions on our daily quiz on how we did this. So this is a good refresher on what you're supposed to have done today. Multiply by the 12, or cross multiply really. So I'm going to have 12 sine of 134 is going to equal 23 sine C. All right, what do I do next? Divide by 23. I don't divide by a sine. I can't divide by a sine. That sine of C is 1 unit. All right, it's not two things multiplied together. So I divide by the 23, and that gives me sine C is equal to that. So I stick all of that into my calculator and get a number. 0. What? 37. Okay. And then, yes, we didn't inverse it. And so I'm going to say angle C equals inverse sine and I get C equals what? Okay. And so I have angle C. We had already found it side A. And so once I get that second angle, yes, I just subtract this angle and that angle from 180. And you told me it was what? Question there? So once we have this angle and this angle, to find the third one, you subtract those from 180, right? Yeah. Well, we're finding all 6 parts. Yeah, so just like we did last time, we're solving the triangle out. So the only thing different today is my very first step, I could not use law of sines because I didn't have a pair of information. So you're using law of cosines first, then use law of sines, subtract from 180. There we go. All right, for the first 4. For the first 4. All right, try number 2. Try number 2. My third one. Could have 3 parts, right? So they. Oh no, just 2. Yep. 3 parts that I need to find. The only 2 nodes. Yep. So at the very beginning, I looked to see, I don't know which law of cosines. Which angle do they give me? All right, answers are on the board. First, is that what we got? What'd you get? So you got 73 and 28.9. Okay, so that one's okay, they're around there. Did anybody get something that's clearly well off? 25? Well, when you use law of cosines, did you use law of cosines to find B or C? Well, sorry, my fault. Yes, law of cosines to find A. So after you did law of cosines, you use law of sines. Did you use law of sines to find B or C? Use law of sines to find B? And you got 29? Okay.
Is it already rounded?
All right. All right. So now this right here, this is important. This is an example of when you did need to go smallest to largest. Okay, so let's start.
For B, I got 28.9, but for C, I got 7.
Yeah, okay, that's fine. Yeah, it's because, yeah. All right, so if I plug in, I don't know what A is. Now,
I needed only need you to get 0.48.
so I'm combining steps just a little bit. I'm gonna go ahead and start with my square root.
Number 3.
No, number 2. 9.7. So I got 30.386. So there's my A. Okay. Let's round up. From there, I need to plug into my law of sines. And I need to use the smaller of the two sides. The smaller side is B, so I'm going to plug into B. Sine of B over 15 equals sine of 78.1 over Okay. Instead of cross multiply, I'm just going to multiply the 15 over there because I know the sine of B is what I want. And then do my inverse sine of that. So I have 15 sine of 78.1 divided by that number right there. And I get 0.483 something or other. What do I do next? Inverse sine of that. And I get 28.883. All right, so mine rounds to 28.9. Okay, but that's because when I was using right here, I didn't use 30.4. I used the entire decimal. So I got angle B is equal to 28.9. And then from there, just going to subtract 180 minus 781 minus 28.9. And there's my 73 or 72.9. Questions on number 2? All right, we're going to do our 5-minute break right there. All right, so answers to 3 and 4. Hopefully you got them from yourself and whoever you found. Those are them on the board. Do I have a question on 3 or 4? Okay. All right. So what?
They're gonna make up their mind because sometimes they use the rounded number and sometimes they use true number.
All right. We are going to skip ahead just a little bit to number 9. Flip over to number 9. All right. So draw a picture of number 9's triangle. Okay. Just draw a picture of the triangle. Yep. Yep. Now, you may have drawn yours a little different from mine. Okay. It may be arranged a little different, but regardless of how you drew it, assuming you drew it correctly, you would have both side 10 and side 11.4 touching 28, right? Because the only side not touching that angle would be side A, and we're not given side A, okay? Now, can you notice that for 9, 10, 11, and 12, all four of those problems are an angle and then two sides that would have to touch that angle, right? We know that because they didn't give you the opposite side, all right? Are we okay with that? So what I'm about to show you only works for this situation. Now, way back in geometry, we had a name for this situation. Anybody remember what it was? We called this the SAS case, side, angle, side. You had two sides and the angle was in between them. You remember that? Okay. So this rule for finding area only works for side, angle, side. Okay. Now, normally, when you're trying to find the area of a triangle, what do? Yeah, base times height divided by 2. The problem is that works really well if I have a right triangle and I know the two legs of the right triangle, because those are always the base and the height. But if it's not a right triangle, which we're seeing in this chapter, not right triangles, what do? So, I mean, I could go ahead. I could like draw a line down the middle of it, and then, but it wouldn't necessarily. It's probably not going to be half that angle. Yeah, no. So that, I don't even think that would work as far as finding. So we have a different way. Okay, complex formula. Pay attention. All right. Nope. I would. Yes, yes, I would write this down. All right. Or alternate way of writing it. Okay. The reason why for the second one is the letters are not necessarily always going to be angle A, side B, side C. Okay. They sometimes mix up letters. Sometimes they use X, Y, and Z or whatever. It doesn't really matter. You put one side there, and you put your angle there. Okay. So for our problem, area equals 1/2 or 0.5. That's fine. What's my first side? 11.4. What's my second side? 10. Did anything matter about which order I put those in? No. And then sine of my angle, 28 degrees. And I can stick that in my calculator just the way it looks. So it says round to the nearest tenth. So yes, round to 1 decimal place. What do you get? 0.8 what?
You just got into this.
That's it.
Oh.
There will be one of those on your test. That is the easiest question on your test. Please don't get it wrong.
And that's what's test.
Yeah. No. So that's why I rewrote it right here in purple and just said first side, second side, your angle. It makes no difference. Yeah, no, it didn't even matter. I could have put the 10 here and 11.4 there. I could switch them. Doesn't matter. Now, if you notice, all right, so there's that entire page is area problems, right? All right, we are doing the first 4 today. The last 4 are different. Now you can probably hopefully look at them and see that clearly the last 4 are different. Okay, they're not hard, but they're different than what we're doing those. We'll do those tomorrow. All right, go ahead and find the area of the next 3. So 10, 11, 12. Should take you all of like 5 seconds to find those 3. So go ahead and answer 10, 11, and 12. Well, if you kind of do the one time. This was the daily quiz you took Monday, not today. A lot of time.
Give me a bit of.
You gotta give it a lollipop, you know, when you give me the Red Bull, and you say you don't want a Red Bull, you want to give it a Red Bull. I did, I seen it right there, and I was like, you can't have no candies. It was right there. He was like, and then he was such a gremlin, he snatched it without you knowing. So like, no, my fault. You make your Red Bull. You have that Red Bull. No, what's the worker? He asked me. I said, yeah. You said it's like, you know, you slap my neck and you get that clap.
Okay.
Yeah, I missed off. I know.
I got the.
I didn't submit my application. I should have be right by.
All right, check your answers off.
Yes, I got you.